This is section 3.9 on related rates. Okay, these are all word problems. Right? So in related rates, we are differentiating with respect to t, time. Every variable from the chain rule needs a d variable dt when we differentiate. Okay, so that means x would need a dx dt, y needs a dy dt, and so on. Okay, so example, x squared plus y squared equals 1. For implicit differentiation, you might recall we said, okay, if there's x involved, we just take the normal derivative, 2x. But y, assuming it's a function of x, we make it 2y dy dx equals 0, and etc. Okay, for related rates, every letter needs a d letter dt. So same equation, x squared plus y squared equals 1. Notice it's 2x dx dt plus 2y dy dt equals 0. Since we're differentiating with respect to t, we assume both x and y are functions of t. So from the chain rule, they both need a dx dt or dy dt, as the case may be. Right? So let me show you the problems. We have to do 1 to 13, 17 to 23, 29 and 37. So let me go ahead and try to show you this. Okay, it's on page 249. So that's up until about 5, 7, 9, 11, let's see, 13, 17. You didn't have to do 15, I believe. Yeah. 19. 21. 23. And let's see, 23 and 29 and 37. So where is 29? Okay. 29 starts at the bottom there. Down to there. And then 37. Okay, there we go. All right, number 1, volume is x cubed. So they just want dv dt in terms of dx dt using this Leibniz notation, the d notation. So the derivative v with respect to t is dv dt. Derivative x cubed is 3x squared dx dt, and that's all they asked for. Okay, number 5. No, it's hard to jump back and forth, but number 1, v is the volume of a cube with edge length x. As the cube expands as time passes, find dv dt in terms of the x dt. Okay. Okay, problem number 5. A cylindrical tank with radius 5 meters is being filled with water at a rate of 3 meters cubed per minute. How fast is the height of the water increasing? Right, so here's a cylinder. You're told the dv dt, rate of change of volume with respect to time, is 3 cubic meters per minute. Formula for the volume of a cylinder is pi r squared h. You're given r is 5, so volume is 25 pi h. You're going to differentiate with respect to time. dv dt equals 25 pi dh dt. So every letter gets a d letter dt. Okay, I plug in 3 over here. 3 equals 25 pi dh dt divided by 25 pi. So dh dt is 3 over 25 pi. And the units is meters per minute. Okay, 11, you're given a sphere, x squared plus y squared plus z squared equals 9. Getting you a setup for Calc 3, I guess. X squared plus y squared equals 9. Circle, center of the origin, radius of 3. X squared plus y squared plus z squared equals 9. Sphere, center of the origin, radius of 3. Anyway, dx dt is 5, dy dt is 4. Find dz dt at the point 221 in 3 dimensions. Okay, so I differentiate with respect to t. Every variable gets a d variable dt. So x squared becomes 2x dx dt. Y squared becomes 2y dy dt. Z squared 2z dz dt equals the derivative of 9 is 0. Okay. And I can multiply both sides by 1/2, which means I can lose the 2 here. So x dx dt plus y dy dt plus z dz dt equals 0. And I can plug stuff in. So x, y, and z are given to be 2, 2, 1. Okay, so 2 goes here, 2 goes here, 1 goes here. Dx dt is 5, that goes there. Dy dt is 4, that goes there. So that gives me 2 times 5 plus 2 times 4 is 18 plus dz dt is 0. And so 18 plus dz dt is 0. So dz dt is a negative 18. Rate of change of z with respect to time. Okay, here is 13. 13, a plane flying horizontally at an altitude of 1 mile and a speed of 500 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So here's the picture. 1 mile up, traveling 500 miles an hour. I call that x, I'll call that y. Find dy dt, the rate of change of the distance from the radar station. So Pythagorean relation, I have x squared plus 1 squared is equal to y squared. Okay. So x squared, I'm told y is 2, so I can find x. X squared plus 1 is 2 squared. X squared is 4 minus 1 or 3, so x is radical 3. I have that. I also know dx dt, 500 miles per hour. Okay, so x squared plus 1 equals y squared. Differentiate with respect to t. Derivative of x squared is 2x dt. Derivative of 1 is 0. And derivative of y squared is 2y dy dt. Divide both sides by 2y. 2's cancel out. So dy dt is x over y dx dt. And then I plug in. Dx dt, rate of change of the plane, is 500 miles per hour. X is radical 3 and y is 2. So that comes out to be 250 radical 3 miles per hour. Rounded off is 433 miles per hour. 17. 2 cars start moving at the same point. One travels south at 60 miles an hour. The other is west 25 miles an hour. At what rate is the distance between the cars increasing 2 hours later? Okay. So I'll call it x, y, and z. 25 miles an hour, that's dx dt, rate of change of x with respect to time. Dy dt is 60 miles an hour, rate of change of y with respect to t. It said after 2 hours. So after 2 hours, if I drive 25 miles an hour for 2 hours, that's 50 miles an hour. Sorry, 50 miles. And y would be 120, 60 miles an hour times 2 hours, 120. I can do my a squared plus b squared equals c squared, 50, 120. You can work this out to be 130. You might remember from trig, perhaps, this is a 5, 12, 13 right triangle. 5, 12, 13, 50, 120, 130. Otherwise, just use a Pythagorean theorem. If one side is 50 and the other is 120, hypotenuse is 130. All right, so x squared plus y squared equals z squared. Differentiate with respect to t. 2x dx dt plus 2y dy dt plus 2z equals, 2z dz dt. And then I plug in. So 50 goes here, 25 goes here, 120 goes here, 60 goes here, 130 goes here, and then I solve for dz dt. Okay. And then your answer is going to be so many miles per hour for 17. Okay, 19 is sort of similar. A man starts walking north at 4 feet per second from a point P. 5 minutes later, a woman starts walking at 5 feet per second from a point 500 feet due east of P. At what rate are the people moving apart 15 minutes after the woman starts walking? Okay. Get this thing focused here. Okay, so the man is here, P, walking north 4 feet per second. The woman, 500 feet due east, walks south 5 feet per second. Okay, and let's get the same units. We're mixing up minutes and seconds. So 5 minutes later, that's 300 seconds. Okay, and then 15 minutes after the woman walks. So the woman walks 15 minutes times 60 is 900 seconds. The man walks for 5 more minutes, so 20 minutes, which is 1,200 seconds. Right, so 1,200 seconds times 4 feet per second. The man walks 4,800 feet. The woman walks 5 feet per second times 900 seconds, 4,500 feet. Okay, so here's a picture. I drew this as 500. I come down like that, so I get a right triangle. Okay, so I call this x, that's y, that's 500, that's z. So I have x plus y squared plus 500 squared is equal to z squared. Right, so the grand total that the two walked was 4,500 plus 4,800, which is 9,300. So 9,300 squared plus 500 squared is z squared. Z is approximately 9313.43. Okay, and now the Pythagorean relation, x plus y squared plus 500 squared equals z squared. Okay, differentiate with respect to t. 2 times x plus y times the derivative of the inside with respect to t, dx dt plus dy dt equals 2z dz dt. Okay, I can cancel out the 2's and divide by z. So dz dt is x plus y over z, dx dt plus dy dt. Now I plug everything in. X was 4,500. Here, y was 4,800 divided by z, which was 9313.43. dx dt, the woman's rate is 5 feet per second, plus the man's rate, 4 feet per second. It's y. Grind it all out, 8.9 feet per second, roughly. Okay, 21. The altitude of a triangle is increased at 1 centimeter per minute. The area is increasing at 2 centimeters squared per minute. At what rate is the base of the triangle changing? So that's dB dt when the altitude is 10 and the area is 100 centimeters squared. Okay, so get all the data down. Area of a triangle is 1/2 BH. Okay, I don't like the fractions. You can avoid the fractions by multiplying both sides by 2. Okay, so 2a equals BH. We're looking for dB dt. So h is 10, a is 100. I can solve for b. So area is 1/2 base times height. 100 equals 1/2 base times 10. So 100 is 5b, b is 20. All right, so again, multiply by 2 to make it a little bit easier. 2a equals bh. Now I differentiate with respect to t. So the derivative of this is 2 dA dt. This is a product rule. First times the derivative of second, b times dh dt, plus second, h times the derivative of first, dB dt. Okay, this is 2, this is 20, this is 1, this is 10. Okay, so dA dt was given to be 2 in the original problem. Okay, I worked this out as 20, and this is 1. So 2 times 2 equals 20 times 1 plus 10 dB dt. 4 equals 20 plus 10 dB dt. Subtract 20, negative 16 equals 10 dB dt. So dB dt is negative 1.6 centimeters per minute. 29. So let's see. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute. Its course is such that its pile is always in the shape of a cone whose base diameter and height are always equal. So this diameter and the height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? Okay. So dV dt is 30 cubic feet per minute. Okay, so h is 10. Okay, if h is 10, then the diameter is 10, that means r is 5. Okay, the diameter is equal to the height. Okay, 2r is the diameter, so that's equal to height. Height is 2r, so r is h over 2. Okay, the formula for the volume of a cone is 1/3 pi r squared h, but I know that r is h over 2. So I'll put 1/3 pi r h over 2 squared h, and that's 4 times 3 is 12, so pi over 12 h cubed. All right, so now I'm ready to differentiate. dV dt is 3 comes down, hits pi over 12, that's pi over 4, h squared, dh dt. Okay. And now I can plug in. 30 goes here. H is 10, so 10 squared goes there. So 30 equals pi over 4 times 100, dh dt. This comes out to be 25 pi. Divide both sides by 25 pi. So 6 over 5 pi feet per minute is dh dt in this particular case. Okay. And let's see, 3.923 is kind of similar to one we already did. .923. At noon, ship A is 100 kilometers west of ship B. Ship A is sailing south at 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m., which is 4 hours after noon? Okay, so similar kind of theme we have here. So A is going south, 35 kilometers per hour. B is north, 25 kilometers per hour. It says 4 hours because that's from noon to 4 p.m. So 25 times 4 is 100 kilometers. 35 kilometers per hour times 4 hours is 140 kilometers. They are 100 kilometers apart. So I went up like that to get my right triangle. Call that x, call that y, 100z. So again, I have x plus y squared plus 100 squared is z squared. Okay, 140 plus 100 is 240. 240 squared plus 100 squared is z squared. Solve for z. It comes out to be 260. This is actually a variation of a 5, 12, 13, believe it or not. 5, 12, 13, double it is 10, 24, 26. And this is 100, 240, 260. So z is 260. Okay, differentiate here with respect to time. So 2 times x plus y, then by the chain root times the derivative of the inside, dx dt plus dy dt, plus the derivative of 100 squared is 0. Derivative of this is 2z dz dt. So every letter gets a d letter dt. Divide both sides by 2z. 2's cancel out. So dz dt is x plus y over z, dx dt plus dy dt, and there we have it. That's 140, that's 160, that's 260, 35 plus 25. Punch it in your calculator, and your answer is kilometers per hour. Right, so that was section 3.9.